All right, guys, we're back with an example here because one of the things we can layer on to the gas laws is stoichiometry. And we all remember stoichiometry. We did a lot of balancing equations utilizing moles and grams and all that other stuff. So what we're going to look at right now here is an example. We have methane reacting with oxygen, giving us CO2 and H2O. What's going to be really important about this is that you have the states of matter here. And you can see we're working with 4 different gases. The first thing we're going to do is balance this equation. Balancing this one's not too bad. 1 carbon, 4 hydrogens. We got 2 over here. So we need a 2 there, and we need a 2 there, and we're done balancing this equation. So there's that. If you can see this first question, a 5-liter container has 4 moles of CH4 and 8 moles of O2. At 0 degrees Celsius, what is the pressure? Well, we're going to use the ideal gas law. So we get P, what's the pressure? Our volume is 5 liters, and that's going to equal, and this is where it's not bad, you just got to make sure you have a total number of moles. Our total number of moles is 4 plus 8. That gives us 12 moles, times 0.0821, because that's our ideal gas constant. And our temperature is 0 degrees Celsius, that's 273 K. And now it just becomes an algebra problem. We're going to divide this side by 5 liters. We're going to divide this side by 5 liters, and we'll get pressure equal to 53.8 ATM, which is like obscenely high. But still, it works. So there's our first one. As we jump down here, what is the pressure in a 20-liter container if 5 moles of CH4 reacts to form CO2 and H2O at 127 Celsius? So what we have to do here is we have to do our stoichiometry. The first order of business, because we're looking for pressure, is to take that 5 moles CH4, okay? Once we do that, we're gonna figure out how many moles of CO2 and H2O we form. So first, it's 1 CO2 for every 1 CH4, and that gives us 5 moles CO2. And we get 5 moles CH4 times 2 H2Os for every 1 CH4, and we get 10. So our total number of moles here is going to be 15 moles. And now we're going to use the ideal gas law once again, and when we use that, we're going to be able to figure out the pressure. So pressure times 20, there's our volume, equals 15, number of moles, times 0.0821, times, at 127, 273 plus 127 gives us 400, and so this is going to be 400. I know I ran out of room there. We're going to do our algebra again, and we get a pressure of 24.6 ATM. We're just solving for P there. And then lastly, down here, what volume, see we're looking for V of O2 at 2 atmospheres, is needed to make 6 moles of CO2. So we're going to walk through this. It's still the ideal gas law. We're just going to have to do a little bit of stoichiometry. 6 moles of CO2 because we're looking for O2. So here we get 2 moles O2 for every 1 mole CO2. So we get 12 moles of O2. And now we're just going to plug it into the ideal gas law. It's the same thing over again, except you have pressure, 2 atmospheres. We're trying to find volume. We know we have 12 moles, 0.0821, never ever changes, and it's at 50 degrees Celsius. So 50 plus 273 gives us 323. And we're going to go through, and we're going to get a volume of 159.1 liters. So that's how we can incorporate stoichiometry with the ideal gas law. The next video I have is going to be another example of that, and it's going to be a little bit more complicated because not everything is going to be a gas.